Okay, let's continue with the content of the last class. We talked about the memory power supply, CPU power supply, and voltage stabilizer, VLDU power supply in the last class. In addition to these power supplies, there will be also a power supply called level-to-level on Apple MacBook. I believe that we had also mentioned this in the previous course on MOSFET. So why is it used for a level-to-level power supply? It is mainly for the laptop interface and small ICs to send power. It is also very important. The power on the interface side of fan, screen, hard disk, touch, etc. All are provided by level-to-level power supply. Its short circuit will also cause the laptop to not boot. In general, its damage rate is also quite high. It is done by one of the MOSFET. What is level-to-level? What does the so-called level-to-level mean? That is when it is working after the MOSFET is turned on. D-pole and S-pole voltage are equal. No size, no change. We call this kind of circuit level-to-level. What is its function? Its role is also very important. Supply power to the interface and small ICs of our Mac. So which interface does this interface include? For example, our fans, screen, hard disk, and optical device, etc. Or need the corresponding working voltage. Then we can know that the level-to-level power supply is also more important here. Check it while repairing. It starts to work when CPU power supply and memory power supply work. These small circuit failures under overall repair. Many of maintenance staff had neglected this part. So the power supply is broken, which only causes the interface not to work. In fact, it is short-circuited and it will also cause the MacBook to not boot. Then let's take a look at this level-to-level power supply. On our laptop, how does this circuit work? Generally speaking, it is from 3V to 3V and 5V to 5V. It is generally completed by a MOSFET control. Then let's take a look at this general structure. The general structure is like this. It has a MOSFET. This is a G-pole and S-pole of the MOSFET, or D-pole. Then it has a resistor R, if it is 3V or 5V. This is a PMOS. This is a G-pole. Generally, it is 3V or 5V. Then it is completed by the PMOS. Then soft bridge PCH sends out the switch signal to turn on our MOS. So the G-pole of this MOS becomes zero state. Make this PMOS because the G-pole is smaller than the S-pole. The mode does work. Its electricity flows from the S-pole to the D-pole, which is used as a secondary power supply, as long as you see the MOS marked on the drawing in the circuit diagram. This kind of circuit in which the voltage of D-pole and S-pole does not change. is collectively referred to the level-to-level power supply. Different model has different numbers of MOSFET. But in the circuit diagram, it is centralized. The distribution on the board is scattered, but on the drawing it is together. When working, it depends on this 3.3 volt high level, and conduction becomes 0 volt. Remember, it is a PMOS, so the G pole is smaller than the S pole, and the MOSFET start to work. From the D level output to our load. Behind our interface. There are also small IC, such as audio IC, etc., which all need power supply. So that's the reason why level-to-level power supply is relatively simple. Because of its simplicity, many repairmen have omitted this part when they are repairing. Cause failures can be solved. We must not repair the machine carelessly. Next, let's see how such a level-to-level power supply is through the circuit diagram. Okay, let's take a look at the level-to-level power supply on our MacBook. This one belongs to the level-to-level power supply. Look, this is Q7830, Q7820, Q7840. Similar to this circuit, this is 5 volt to 5 volt. Let's take a look at the voltage marked on the drawing for the S pole and the D pole of each MOSFET. Look at the Q7820 below. It comes in 3.3 volt and goes out to 3.3 volt. Its voltage has not changed. This voltage are used to send power to the tiny interface and small IC that provides with power. This kind of circuit are also relatively easy to break. Because our loads are all interface device, or interface device MOSFET, resulting in notebook does not boot, or an interface cannot be used. Generally, this kind of interface is used for level-to-level power supply. Look at this tube, it's S pole in. Let's zoom in and take a look. Take the Q7830-2, which is 3.3 volt in first. The soft bridge receives a 3.3 volt switching signal to the G pole of the Q7812 of the MOSFET, generally measured to be 3.3 volt. After switching, it sends out switch signal. But here I want to talk about this switch signal. Generally, between soft bridge and this one, it is connected with a gate circuit in the middle, and the circuit is converted. This situation occurs when there is a gate circuit conversion. If this pole doesn't have 3.3 volt, you have to follow the English name to find the upper level IC. Here it turns on again to make the D pole grounded to the 0 volt state. Then the G pole of Q7820 is connected to here. Take a look. Then it may turn on, that is, our G pole becomes 0 volt. It is predicted that it is a PMOS. We talked about it in the basic course. The PMOS is G pole smaller than the S pole, and it can work above 2.5 volt. And it is at 3.3 volt, it is 0 volt. Because the G pole is smaller than the S pole, the MOS start to work. This is the third step. The fourth step from D pole output, 3.3 volt is our load. Including the circuit Q7820 and Q7840 mentioned later, the working principle of the circuit is the same. I won't let everyone to analyze them one by one, but the power supply like this should also be checked in maintenance. When this kind of power supply is repaired, generally speaking, as long as it is not short-circuited, generally we don't check it. Directly connect the D pole and the S pole with a wire to make it uncontrollable. But this kind of drawback is that the electricity is not controlled and may cause electricity, but it does not affect reuse. If you want to refine it, check the G pole part. In the daily maintenance work, a load master connect the D pole and the S pole to it. No refinement of the G pole. It saves cost and time and improves the maintenance efficiency. This is working principle of level-to-level power supply. So how do we determine whether this level-to-level power supply is damaged in maintenance? First of all, you have to test whether the D pole has a corresponding working voltage. If it is said that during maintenance, is there any depot to be tested first? If this 3.3 volt, it should be 3.3 volt power supply. If there is no 3.3 volt, it means that the level-to-level power supply circuit has been damaged. Generally, when we repair it, check the resistance value first. Check the resistance to the ground to see if there is a short circuit. If there is a short circuit, we usually put the back end. Of course, there will be a capacitor. First, remove the capacitor connected to its load. If there is no short circuit, the value of this level-to-level power supply to ground is more than 200. If it is within 200, generally it is a short circuit phenomenon. If the value to the ground is within 200, it is considered as a short circuit. We usually connect it to the capacitor, and there will be a capacitor in the back end. You will find a few capacitors at that time. We usually remove them. If there is no short circuit, you can see if the depot has power. On the other hand, first look at whether the depot has power. If the depot has power, first look at the S-pole. If the S-pole has no electricity, you can check to the next level. MOSFET of the S-pole also had electricity. Because of the S-pole is 3.3 volt standby voltage, the standby from the 3.3 volt large inductor was triggered. As long as it can be triggered, S-pole does not need us to measure. The key is whether the G-pole has 0 volt. If the voltage of G-pole is not 0 volt, it is necessary to check the relativity of the signal of the G-pole. Q7822, Q7820, we need to look up these components. But it's troublesome to find out in this way. In maintenance, we all carry out maintenance according to what I just said. Use S-pole and D-pole to find this component on the big map. Connect these two pins to it and they can be repaired. This kind of power supply is relatively simple to repair, including our Q7840 live circuit. First check its resistance value and then test it when it is short-circuited. Pull out the capacitor connected to it. Generally, if you search by looking for the load, there are capacitors in the back end. It's a key point here during maintenance. Let's have a look. We all have 0 ohm resistor. Such resistors are also easy to damage and burn easily. It plays an insurance role like R7814. Including the above R7821, this kind of resistor can be shorted connect. So it is relatively simple for it to repair MacBook. But check it carefully, okay? As long as you are careful enough, it is easier to repair a circuit like this one. Like the 5 volt power supply tube, we all find it more convenient. As long as it is not short-circuited, we can connect the depot and S-pole here. If there is a short circuit, we will remove the capacitor at this back end. See if there is an IC at the rear pole. Remove it and solve the problem. This is a maintenance method of the level-to-level power supply. Goodbye.